So I was going to start streaming earlier today, but I realized just now that I have a problem, and as always, there could be several different ways to solve this. So I think what I'm gonna do is just to talk about the notes that I took, and I highly recommend to watch this lecture here because I'm gonna be talking about the notes that I took from this lecture about game engine architecture and the stuff that I'm thinking about because I'm not gonna follow exactly what he said. And there is the main stuff that I'm thinking about now is the events. So uh, right now I'm on the step where I'm going to create the engine class, and then I'm going to create scene classes, and I'm going to restructure everything that I have so far. So in order to do that, I have to think about the overall design and architecture of everything to make sure that there is lower chances that I have to refactor everything later. So the main thing that I'm thinking about and that is challenging now is to figure out what is the best way, because I'm going to be using IMGUI as the GUI elements, which I might change in the future because I realize that IMGUI is designed for debugging tools specifically and not for the for the GUI elements of the app itself. It's more designed to create debugging tools. But I couldn't find any other library that I thought it was good to develop GUI elements, and I think people usually develop their own. So I'm not really sure if I'm going to replace or not. So this is one thing. So I have to keep in mind that in the future I might have to change the way that I'm doing everything. But the biggest problem is that IMGUI has their own event system. I don't think I'm not 100% sure if they have an event system or not. The way that I'm thinking about now is that the connection between IMGUI elements and my application is going to be done through data. And it's kind of hard to think about the relationship between the GUI elements and the application elements and how that's going to be related to everything else. And the documentation is not very great for IMGUI to understand what is the best way to divide them. But the biggest thing that I'm thinking about now is that I'm using GLFW to create the window. And on GFW, I have this, you can set up callback, you set up callback functions when right after you initialize the window to capture the whatever happens with the events. So GFW handles the events, and based on the callback functions, it allows you to put your own functionality to deal with the events. But the issue is that you have to follow the blueprint of the way that they want you to set up the function. So this is the challenge that I have now because I don't know how I'm gonna change the way I have here, which is a way that I got from Raylib to use the engine class instead of these functions here. Because what I'm thinking about, so the way that Raylib works is that they have this global object here, and then they just capture the states they just change the state of this global object based on whatever happens with GFW. And what I want to do instead is move this to the engine. So this is the thing that I'm thinking about now. But I think I'm going to go over first the notes that I took there and the SkyDraw flowchart that I did. Also, another thing that I want to talk about is this Anki thing. So this is something that I was thinking about some time ago where I wanted to create something like this for Softavis when I was building the front end. I was thinking about that. But it didn't occur to me to search for other things that are like this. So the idea that I have was to build like flashcards to memorize the encoding of ASC or UTF-8 characters, just because I thought that like the more stuff that I have on memory, then the easier it becomes to do things because it becomes a lot more. It's like clarifying your mind. So recently, as I was learning all this stuff, I saw a video from someone learning Vulkan, and then they mentioned this app which is called Anki, and this is an app that has exactly what I was trying to do. So it allows you to build a bunch of flashcards, and then you can train. Usually, people that do this are for medical school. So I think it would be cool if people from programming did this, because one thing that you can do is just go on here on Get Shared after you install the app, and then it takes you to this page. And then you can search decks for that people have done, and this is what I've done. And all of this so far are from other people. So I think eventually once I finish, so the idea that I have is should we hit around 1,000 for each category that I have there. And once I get to that point, then I think I'm gonna create my own. And the main thing that I was thinking about is to memorize the methods on C++, for example, or other stuff like that. So I think it would be cool if people did this and then shared on GitHub or somewhere else. And yeah, it's free and it's very effective. So I'm just gonna show a little bit. So this is for PowerShell commands, but I'm not gonna do this now. So there are several different cards you can use. This one I think is the most useful to memorize commands, and is the one that I'm thinking about doing for example, memorizing stuff from the standard library from C++ and the methods, so I don't have to search this stuff every time that I think about it. Because the main thing that I'm trying to figure out is fundamental patterns, then memorize fundamental patterns, so I don't have to research. But yeah, so I'm not gonna talk about this too much, but there are several different types of DAX, and it's something that I found interesting to see. And this is the playlist from the guy. Go watch all the videos. Highly recommend. And now let me talk about the notes that I took. I also was reviewing a bunch of stuff from mathematics to refresh my mind on how everything works. So these are the notes for the current snap. Oh, another thing that I found is this animation thing. But I'm gonna talk about this. I'm gonna talk about the notes first, then I'll talk about this animation website. So these are both from a book of game engine architecture, which I thought that the title of this book is a little bit deceiving because most of the book he spends talking about stuff that's not necessarily related to the architecture, more what each part of the architecture does. So this is, I didn't like that very much, but there is a lot of useful info as well. But I don't think I wrote down many things here. One of the things that he mentions is that on Windows there are different types of characters. So there's different types that Windows uses to determine different types of characters, which is something that I didn't realize. I remember looking into some source code, and then I didn't understand why they use typedef for specifying some chars, but now I understand is that these different ones here, they specify different ways of encoding characters into numbers. And I think he got this from somewhere else that I don't remember. Design of a game engine's memory allocation subsystem. Oh, also the thing that the guy talks about on the game engine playlist is that the way that he did the playlist is not necessarily for like the most effective. It's just a trade-off between efficiency and how easy it is to teach this stuff. It would be nice if he did another playlist or other videos explaining. He says it's AAA games, which is AAA games is apparently like the more effective way that people do. Like, so he mentions some parts that he says that it could be more optimal if you did it like this, but I'm gonna do it like this because it's a trade-off and all this stuff. But I think I'm gonna follow the stuff that he said first, and then I'm going to over time optimize. So the design of a game engine's memory allocation subsystem is usually closely tied to that of its resource manager. So this is from the book, not from the videos. This is the game loop that he says is usually the way that it's done. So update objects, animations, process the joints, detect collisions, runs physics, update cameras, and render scene. Then animations. So this is the equation that they call lerp. I forgot what it stands for, but there's lerp and slurp. So it's lerp and lerp. And they're both mathematical equations that interpolate. So they're functions that interpolate different values between a range. And then you use these functions to create the animation effect, which was kind of confusing. I guess it's just linear interpolation. to me, but now I realize that the way that it works is that, so this is the website that I was talking about. So this here, they provide the code in JavaScript for each one of these functions. And like the nature of the function just determines the slope, which is how fast the transition is going to be. So the way that it works is that you pass a initial state and a final state to the function. And then I think it's going to interpolate where it's at in the middle of those states by doing like it's just, I think it's subtracting and then dividing by the overall distance. And then it just gets, like, it calculates the ratio of where the point is at in the path. And based on that, the way that you animate is just by calling this function and replacing the current value of x with the beginning each time on the animation. And then you put the final value of the position that you want in the end. And then there's some other stuff that if you're going to use textures, you use a texture atlas, and then you can put all the frames of the animation inside of one image, and then it's on the loop. It just goes from when it gets to the final step of the image, it just goes to the beginning and then creates an infinite animation. But for my case, what I was thinking about, so what I am going to do is just go one by one and then copy these functions on a file. And the way that I think it works right now is that each step of the iteration, you put the current value of x on the function and the final value, which is the target position. On the other example, they use 3 different values. So I'm not really sure why it's only 1 here. But then you update the value as with the result of the function. So it's like you're putting the current position on the function, and then you update each frame, because you're going to make that new value, which is the result of the interpolation, should be the starting point of the next frame. And so it's pretty much like you're walking through the function. And the only thing that matters, so the way that I'm thinking about it, using on the stuff is on the graph algorithm. So you run an algorithm to calculate the positions on the final layouts. And then based on that, you have the final position of x. And then for each thing, you just pass the current x, and then each time it's going to calculate. So it was confusing because I didn't understand like this relationship between frames and the function. I think this is some other channel that I saw that he explains, but I don't remember which one. I think it's Coding Train or something like that. But I'll do this another time. A lot of animation calculations based on Granger mechanics and derivatives. To implement animation, just make the value of position should be equal to the results of the lerp function for the current position and the final target position value. In the case of graph layouts, the final position would be the final layout. The initial position would be the current one when the position equals final. We can stop calling the function. So the other thing is that there's lerp is the spherical version of the lerp. So it's just for animating rotation. And then that's where it gets very complicated if you want to do... I haven't tested, obviously, so I'm not really sure if the simple ways that it's going to work in the way that I have on my mind. But I can imagine like the challenge on more difficult examples is just calculating the physical effects that you want to calculate the beginning position, the final position, and all the physics that's going to happen in between. And then once you have that, then it is also challenging because of the sequence of the movements. And it's not very clear to me still what is the best way to do all of that. So another thing that I realized is that on the lectures he uses these entities, component systems, which is a composition approach, which means that you're going to create an entity. An entity is just an object in the visualization. And the components of the entity are like kind of like what the entity has, for example. So if an entity is a body, for example, the component would be the arms, the legs, stuff like that. And I realized that the way that I'm doing is fundamentally different, I think, because of the way I got the library from TripPP. So I think that this approach doesn't work for the way that I'm doing, but maybe later on I can use for other stuff. But I think I'm not going to do this way. I'm just going to follow the way that I have there, which is each class has all the inherits from an object 3D class, which is the base class, that has all the data structure and algorithms that you need to translate the objects on space. So my version would be like every entity has the same components, and which are the necessary components to move the mesh on the screen. Just data has some intuitive meaning. Class an entity class that has a bunch of components. In my case, entity would be each mesh, and position and other stuff would be the components. It's a different paradigm. The other thing that I did was change the way that I was doing on the programs class, which I already had in mind, but I didn't. So the problem that I had is that the type on the I'm initializing the mesh with a material type because it has to be generic. So when I create the mesh, I'm passing the type as the material, if I remember correctly. Well, here is this type, but I think on the class itself is the material type. Yeah, it's this type. So the issue is that this type has a member variable, which is the type, and which is the base class for all the different materials, and then the classes that inherit from this one also had the type. And obviously I wanted to make which program is going to be selected based on the type of the derived class, not the base class. But the issue is because you initialize the mesh with the base class type, then if you try to access that type, it's going to complain. If the base class doesn't have a type, it's going to complain that it doesn't have. And if both of them have a type, it's going to get the type from the material, which is the base class, because it's the type specified when you initialize the mesh. And then there's a way to get around this, which is some of the functions that they put here, where you can cast to see what kind of type is going to be. And then if you do that, then you're able to get the correct one. But then the problem is that you have to specify for each one on the programs. So you can do this. So this is a function that they put on the material class, which allows you to cast what kind of derived class it is. And then if I did it like this, I could put this logic here to access the correct type. And then based on the correct type, I could get the value of the relative path. So this is mapping the type of the material with the relative path from the assets folder to the material, to the program files that are going to be equivalent to that material type. So yeah, one way would be to use this, but then I would have to, for each material, I have to put this stuff here, which is not very good. And what I thought about making the type on the mesh itself, but then I realized that the reason why they do it on the material and not the mesh is because you can have a geometry that uses two different types of material, for example. So like maybe you have a cube that you want to put light or reflection on one side, and on the other side you don't want that. So it makes sense that you can have a mesh it's better to have a mesh that you can put different types of material. So compose the mesh with different types of material. So I think the selection of the program has to be related to the material type. So this I got from ChatGPT, which I thought is very good, which is you just create a function on the base class, a virtual function, and then on the derived classes, you inherit from that function. And apparently it's working, so I'm just gonna leave it like this. Because I tested and I console logged here and it was working, so. So I select based on the function, I get the type, and then I filter on I get on the map. And if the map has the relative path, then I initialize the program as that. But maybe I'm probably gonna have to change this later as well, so. Because if you have a mesh that has two different types of material, then I have to change this. But I'm gonna think about this only later because I want to focus on the stuff that I think this is good enough. It's not gonna be that big of a problem later on if I want to have different materials that have more than one, different meshes that have more than one material. So I think it's not gonna be that big of a deal to change the logic. Maybe I'm wrong, but yeah, I think it's worth it to focus on the other stuff now. So the way that he recommends, I took a bunch of pictures from the project. I'm gonna use the pictures as a starting point to write the code for the classes, and then I'm gonna change based on what I have there. So one thing that he says that I think it makes a lot of sense is that you should load assets once and use often. So because apparently assets are one of the slowest parts of the engine, so it makes a lot more sense to load all the assets on the engine itself and then just pass the assets to the whatever scenes are gonna use those assets. So one thing is that this is like the texture is also considered an asset. So I'm not really sure how I'm gonna do it with the texture, but with the fonts I already thought about this before. But now obviously the way I'm gonna do it is just I think that makes a lot of sense. And if you have a game that is very complex, like the more complex the more assets the game has, the more incentivized you are to fragmentalize or separate the assets into specific scenes, or like basically gradually load all the assets, obviously, because if you load all of them at once in the beginning, then it's going to be very slow. So how the amount of assets you have is equivalent to how you should structure the logic to separate them throughout the logic of the whole application. So the way that the problem is that I have to think about how I'm doing the texture there. I'm not sure how I'm gonna change this. Like, because I'm creating I have a label class that is part of that is optional for each mesh. There's a function inside of the mesh that creates the label, and this class has the texture. And I took the font out of the class, and now I'm initializing through dependency injection the font. This class with the font. And this is the one that I'm going to initialize on the engine, which contains the STF font, which opens the file, which is the TTF. It's going to parse everything to create the images. But he also says that the texture is considered to be an asset. So in this case, it's kind of weird because I think it's a lot easier to think about the texture inside of the shader class, but it does make a lot of sense because here the problem is that I'm creating one texture for each different program, which is each different label. But that doesn't make a lot of sense because the image is always the same. So what I'm doing is just creating a bunch of blocks in memory that are separated, one for each label, but they all are going to draw information from the same space in memory, which is the same image. So it makes a lot more sense to store everything, like only create memory for one image on OpenGL inside of the engine, and then share that with all the classes. So I think I'm gonna have to do that now. I'm gonna structure everything first, then I will think about this, because the most annoying part is the events and figuring out how to structure the engine class. But what I think I'm gonna do is that now I'm holding the texture on this font here, and what I'm gonna do is just change the logic. So I probably can do the same thing actually, now that I think about it. So it's probably not that hard actually. So I just move the logic to create the texture, these functions here, outside, and then I just store on the fonts, and then here I initialize the or I just remove the texture from the label shader class. I am using the texture from the font already, so it shouldn't be that hard actually. But that's something I'm definitely gonna do. Let me put here so I remember. So the way that he's doing and that he recommends, which I wasn't sure is the best or not, but now after thinking about it, I think it makes a lot of sense. So the way that it works is that you create the engine, and the engine is going to contain the main loop, and the stuff that's the logic inside of the engine loop, the main engine loop, is going to be the stuff that I have there that is not related to each scene, and each scene is going to be like a page on a website. So the way that I'm thinking about it now is that this comes from the app. So I'm just going to replace whatever, I'm just going to replace basically this function here with the update function from a scene. So this other stuff here is going to go in the engine. So these I'm going to remove or change because these are the events. But I'm going to put this stuff on the engine, and then I'm going to change the state of the engine based on the GFW events. And this other IMGUI stuff that happens on all different scenes, which is just creating the frame for IMGUI and then flushing the drawing. It's also going to happen on the engine, and then the main thing that is going to change is just what kind of components I put here and what kind of components, or yeah, it's just going to be basically this render call here inside of the scene. But now that I think about it, actually, it's probably not a big of a deal. Sure, that big of a deal, sure. Because I just realized the issue here is that the reason why I'm putting this before IMGUI is because if you, whatever you render last is going to be in the front of the thing. So I'm rendering the application, the drawing for the application first, so it's on, it's behind the IMGUI elements. So I have to think about how I'm going to structure this. Because the way that it's going to work is that you do this stuff, create the engine, then you create a scene, and then you map scenes with a string. So you create a cache, which is going to be a map of the strings for each scene. And when you initialize the engine, you initialize with a default scene. I don't remember if I took the picture of this. Also, the way that he recommends to do the events, I'm going to change, which is the main stuff that I'm thinking about now. This is basically the picture of how everything should work. I don't think I wrote it down on the notes. But basically, the engine has a variable called current scene, which is going to be the current scene, and as you initialize the engine, you pass one scene that you created, and every scene receives the engine as a true dependency injection. So the scene has a pointer to the engine, which is this code here, and then whenever you want to change scene, you put on the logic of the scene there's a function called change scene that it should implement change scene, and then you send the new scene to the engine. And think about this. Oh yeah, the scene is there's an abstract syntax class, which is the base class of the scene, and that contains the main framework of the scene, which is just going to be the updates, these functions here. So just basically render and updates and dealing with the basic stuff, and then each other scene, like all of the scenes are going to inherit from this class, obviously, and depending what kind of scene it is, you can put more stuff to handle physics and other stuff. So basically you initialize the scene, you initialize the engine, then you initialize the scene outside of the engine, and you map, you call the, I'm not really sure how, I'm probably not going to do it exactly the way that he does it as well, but those are the kinds of things that I'm thinking more about now. Is like, what is the best way to structure everything? So, because one way would be to initialize the scene as inside of the constructor of the engine. Because the biggest issue is that what happens if you try to call the update method from the game engine and you haven't initialized the default scene. So you have to think about that. So either you can initialize the current scene on the constructor of the engine, and then in that case would initialize the scene, the default scene, which is going to be the main scene when the app starts, and you pass that through the engine as dependency injection, and then you initialize the default as that scene, or you initialize the engine before, then initialize the scene. But the problem is you have to initialize the scene after, because the scene is going to rely on the engine. So yeah, so I think you have to initialize the game engine, Then you initialize the scene, then you call a function for the game engine that's gonna map the default scene, which is the first scene, with the scene char pointer you created. And then, yeah, and that scene is gonna contain the pointer to the game engine. So whenever you want to change scene, you just call the change scene from the game engine, and that changes the current scene. And then inside of the loop, I think he didn't show, but it's probably pretty obvious that inside of the main loop, what you do is just call the update function for the current scene. And something he talks about that I didn't know, but it's kind of intuitive to think about, is that shared pointers are really bad. They make it a lot slower, and I'm not really sure how much slower, and if it really is that bad. But it's something he mentions, and I was thinking about. But obviously, it's a trade-off between convenience and speed. So maybe that's something that I'm gonna have to think later on, probably. And there's also a very useful image that he shares there about malloc flowchart. So apparently this is what happens when you run malloc. And there's a comment that I left there on the series, one of the videos, and he replied. So if you want to get this, just go there. So this pattern is called the finite state machine, the pattern for the scenes. Just changing the current scene, which is the one that is going to be used to update based on the other scenes. And each scene inherits from the abstract class, which contains the template for the minimum requirements of what the scene needs to work. Because that way you are able to call that thing on the function. And then the logic that is customized is going to be inside of the update function of the scene. So the update function of the scene is the one that has the game loop, in my mind. And then it's going to vary between scenes, obviously. So the asset load ones, bigger game assets. Yeah, so the bigger the game, or the bigger the assets, then the more incentivized you are to share between scenes. And I think he creates a scene, an asset class on the thing, but I'm not really sure if I'm going to do that now. Maybe in the future. So the inputs and actions is the main thing that I'm going to change. And so I don't remember really well, but he pretty much creates an action class, and then based on the action class, it passes events, but I didn't like that much. I'm gonna go over the Skelly draw that I have there to talk about what I'm thinking about now, and after that the problem that I have now, and maybe I'm gonna probably solve this off stream, the problem. So I'm gonna stop streaming after that, because as always there's multiple different ways to do it, and I'm not really sure which way is the best. And there's a Stack Overflow answer there that's found really useful. There's also an example from the Cherno, which is the Hazel engine that he has. There might be another approach to do it, and then there's other approaches as well, but user inputs, blah, blah. There are two ways to do actions. One is the action is just data, it gets passed to the scene, and the scene implements the logic. The other is the action class implements the logic itself. He mentions an abstract class for actions, then each action class would have specific purposes. I don't think I'm gonna do that. So either the action is gonna be considered as data or as a class itself. The update render ratio. So this is another stuff that he talks about. So like, this is on the advanced game loop lecture, which I think is the 18. So just recommends to go there to watch. And this is another very nice thing, which is on the lecture 20, I think, which is very helpful. I just copied from him pretty much. So if you watch the lecture and you copy the code, so there's something, and I didn't know about this. There's a special page there are several different special pages in Chrome you can use, and one of them is the tracing page. And then based on that page, what it allows you to do is that if you have a JSON file in a specific format, you can put on the page, and it's going to show you different information for the game. So it allows you to profile. So it basically creates a function using the Chrono library, and then it allows you to put breakpoints on several different parts of the code, and that creates a JSON at the end. And then with the JSON, you can put the JSON here, and it shows how much time each thing took. So that is very nice. So I'm not going to pay attention to this stuff now, but in the future, obviously, it's very easy. So it just shows how much time each thing takes. And it's out. To zoom in and out, you press Alt and then scroll the wheel. So these are the functions. Create a sphere that I put there to test. You just go here and then you paste the result there after copying the code that he has on the series. So this is another thing that he mentions, and this is the thing that is stuff that is related to pointers and to mainly the when he talks about the malloc chart. He talks about it 2 different times, but the second time he talks about it, that he explains that obviously like the slowest parts of the code is going to be allocating stuff on the heap, and usually you're going to do that a lot because it's just a lot easier to encapsulate logic that way, because then you don't need to think about the scope of each thing, and it makes it less likely that you're going to make mistakes and memory leaks, stuff like that. So because of that, and all these classes, I think they do this automatically, the vector class, the string class, and other classes like that in C++. They just keep references of the instances where the thing is used, and the thing is allocated on the heap. And this takes lots of it makes it a lot less performant, the code. So one solution that he talks about and that people do is use a memory pool, which I didn't spend. I have to review this stuff, but I'm probably not going to do it now. But it's an option where instead of initializing, basically the overall way that it works is that you initialize everything on the beginning. You just allocate this massive amount of memory in the beginning, and then you just use that memory instead. Because then it makes it a lot easier. You don't have to create and delete a bunch of times. So the downside is that you waste memory in the beginning, but then later on you gain. So just go watch the lecture. It's the 21, I think. One of the final lectures, cache coherence and memory profiling. Chrome tracing. So lecture 9 is where he mentions the scene for the first place, dependency injection. This is the example he gives there on how to initialize. So you call change scene, which is the function that is used. Change the current scene, which is the value on the engine that is going to use to access the thing. So the engine inside the main loop is just going to call the update function for the scene, for the current scene. And then on the current scene, you're going to have the logic based on the data of the scene of what's going to happen. Game engine stores scenes on the one thing that is not, he has a lecture as well on saving the game, but one thing that is not very clear for me, and this is part of the confusion that I have with the events, is what is the best way to keep track of the state of each scene? So whenever the app is not on the current scene, like how to make sure that what is the best way to save the state for the others and to manage the state of the overall application? Scene should be implements. So I think that's pretty much it for the notes. So I'm gonna show the stuff on the SkyDraw. I'll be right back, and then probably after that I'm gonna stop streaming and just go think about. So I'm gonna show this stuff, then I'm going to talk about this other problem that I realize that I have now. Then I'll probably stop streaming and go try to, or think about which is the best way to solve this, and then try to solve it off stream. I'll be right back. So the first problem, the first difference, which is not very clear in my mind, by the way, because obviously I'm still trying to figure it out, but like there's two different. So there's two different ways that I'm thinking about dealing with events, and there's other videos that I've watched as well, but I think I'm gonna go with the way that I'm thinking about now. But one way, and that's what most of the videos say, which I'm not 100% sure if it's different than the way that I'm thinking about, but as far as I know now, it seems to be slightly different. Which is the way that I think about is you create a class and then you have a subscription system. So you subscribe or unsubscribe from events. And the other way, so this class would be probably in the main engine class. And then you would subscribe from events, to events from that. But I think because I'm using GFW, it probably changes a little bit, because the other way, which is the way that I'm probably gonna do it, is you have GFW, which allows you to put the callback functions that I talked about there at the beginning. So I have these callback functions that it allows you to pass, and then you can put whatever logic you want inside of these functions. And then this other way is the way that Raylib does it, but this way is a little bit weird because it's different. So it's probably the same thing under the hood. So because the experience that I have is from web dev or the events on the front end. So the paradigm, the way that I was thinking about on the events on the front end, is that the logic is only going to happen when the event gets triggered. And I think that here is different because this logic is getting triggered every time, I think. So it's the difference between blocking and non-blocking events, pretty much. So I think that these are blocking events, which means that they happen each time on each frame, because they're changing the state of this global struct here that they use to keep track of how the inputs are changing over time. And the difference between the other approach, I think, is that the other approach is the logic only gets triggered if there is a change. So for example, if the user clicks, then there is something that happens. But I think here, the way that it works is that you are always capturing the state, and then through the state, you put the logic. So, and this changes the way you design the functions, obviously, because, for example, on the wheel events that I was trying to design there, you have to put the logic based on the spreads of the change in events. instead of whether or not the event happened. So for example, for the will event, instead of making a Boolean variable, for example, that determines whether the logic is gonna run, if the will was triggered, the will is always gonna be triggered because they're capturing how much is changing over time. So what you have to do is encode on the logic the spread between the previous frame, the value of the will, and the current frame, and that's gonna give you how much is fluctuating over time. So the downside of this way is that it seems that you spend more computation, because regardless of what's happening, you're gonna have to keep track of you're gonna have to change the data. So I think that's kind of bad if you want to do something, for example, and there is something that they talk about on the GLW page, which is an editor or something like that, where it's like just a static page that doesn't change very often, because then obviously you're wasting a bunch of computation whenever there isn't any events happening. So if you are in a situation where you only want events to happen if there is interaction, then it's probably better to follow the other paradigm. But the problem is I'm not 100% sure how to make the other paradigm works with this, with GFW. Because it seems that the way that is recommended to do is just put these callback functions. And this is the main problem that I have now that I'm thinking about, which is that the way that Waylib does it is based on the struct there, which is a global variable. And the way that I'm thinking about doing is just changing this class changing these functions into parts of, into functions from the engine class. Because then I would be able to have access to the variables instead of the engine. And then instead of using this global thing here, which I don't like doing, I would just move this other structs that exist on the global one inside of the engine. And then I would access this structs directly from the engine. But the issue is that if you do like this, you have to change the signature of the function, because of the way that C is gonna figure out, the C compiler is gonna figure out where is the function located in memory, because the function is part of the class, so it's gonna have an address in memory. So I'm just gonna read the stuff here, then I'll explain the events there, the logic of the events, like the flow of data of the events.
How to GLFW set key callback for different classes? This question shows research effort. It is useful and clear. I use GLFW when I have different classes representing the different states in my application and one state managing class. I want to use GLFW to receive the key input and pass it to the current state, so to another class. The only way I could think of was giving each class an own key callback function and use GLFW set key callback window, key callback with window, in key, in scan code, in action, in mods. It didn't work that way. Cannot convert intro state handle key event from type void. Intro state, window, int, to type ifun, aka void, window, int, GLFW set key callback m_manager greater than window, handle key event. People recommend, but I need to access non-static member functions and get some problems when the callback function is static. The actual question: how can I make the current state class get the key input from GLFW? Like states.back greater than handle key event int. Follow this question to receive notifications. 5 answers 5. Things get much easier when you step back for a moment and don't think in classes at all. Also, a class is a type, and types don't really describe a specific state. I think what you actually mean are instances of a class with different internal state. So your problem then becomes to associate a callback with your state. In your post, you wrote the following incomplete callback signature: key callback with window, in key, in scan code, in action, in mods. There's missing something, namely.
So this is the problem: is that because of the way that GFW works, like you can't specify your own arguments to the callback function that you're gonna pass, because the callback function is gonna have like the same signature all the time. So like I can't, for example, create the engine and then pass the engine as an argument for one of the functions, so I can access the values from the engine.
The type it returns, which is void, so the full signature is void. Full call key callback with window, in key, in scan code, in action, in mods. Word full call is a not further specified macro that expands into additional type signature qualifiers. You don't have to care about it anymore. Then that this is the only type signature you can validly pass as a callback. Now image you'd write something like class foo state void full call key callback with window, in key, in scan code, in action, in mods. What would be the type signature of this? Well, when you actually implement it, you're writing it down. Void full call foo state key callback with window, in key, in scan code, in action, in mods. Look at this additional foo state. This is not just some addition to the name or namespace. It's actually a type modifier. It's like as if you add another parameter to the function, which is what in fact happens. And that parameter is a reference or a pointer. A pointer in the case of C++ to the class instance. This pointer is usually called this. So if you were to look at this function through the eyes of a C compiler, which doesn't know classes, and GLFW is written in C, the signature in fact looks like void full call key callback foo state this window, in key, in scan code, in action, in mods. And it's pretty obvious that this doesn't fit the needs of GLFW. So what you need is some kind of wrapper that gets this additional parameter there. And where do you get that additional parameter from? Well, that would be another variable in your program you have to manage. Now we can use static class members for this. Within the scope of a class, static means a global variable shared by all instances of the class and functions that are within the namespace of the class, but don't work on instances of it. So from a C compiler's perspective, they're just regular functions with no additional parameter. First, a base class.
So what is happening is that when you have a function that is part of a class, then what the compiler is going to do is just replace with this thing as an argument, which references the location of the class. So it's getting so if it figures out what is the address from the instance of the class, because if you initialize multiple different classes, then obviously each one of them is going to have their own function, and then they're going to be on different addresses in memory. So you need to access the instance of the current class.
That gives us a unified interface. //statebase.h. Class statebase. Virtual void key callback with window in key in scan code in action in mods equals 0. Purely abstract function. Static statebase event underscore handling underscore instance. / technically set event handling should be finalized so that it doesn't / get overwritten by a descendant class. Virtual void set event handling event underscore handling underscore instance equals this. Static void key callback underscore dispatch with window in key in scan code in action in mods. If event underscore handling underscore instance greater than key callback window key scan code action mods / statebase.cpp hashtag includes statebase.h / Funny thing that you have to emit static here. Learn about global scope / type qualifiers to understand why. Statebase colon event underscore handling underscore instance. Now the purely abstract virtual function is the trick here. Whatever kind of class derived from statebase is referenced by the event underscore handling underscore instance by use of a virtual dispatch, it will end up being called with the function implementation of the class type of that instance. So we can now declare foo state being derived from statebase and implement the virtual callback function as usual. But emit the global call macro. Class foo state base state virtual void key callback with window in key in scan code in action in mods void foo state colon key callback with window in key in scan code in action in mods / To use this with glfw, register the static dispatcher as callback. glfw set key callback window statebase colon key callback underscore dispatcher, and to select a specific instance as active callback handler, you call its inherited void statebase colon set event handling function. Foo state state.set event handling. A few parting words of advice. If you've not been familiar with these concepts of OOP in C++ and the intricate how types and instances interact, you should not do any OOP programming. Yet, OOP was once claimed to make things easier to understand, while in fact the shrewd ways it got implemented in C++ actually makes one brain hurt and proliferates very bad style. Here's an exercise for you. Try to implement what you try to achieve without using OOP. Just use structs without member functions in them, so that they don't become classes in disguise. Try to think up flat data structures and how to work with them. It's a really important skill which people who jump directly into OOP don't train a lot. Follow.
So this is the problem. This is the reason why I don't like that much, because the way that he recommends here is just create another class, which is going to be the base class, which is going to be the one that is responsible for events. And I'm not 100% sure why it works here. I have to spend more time thinking about it, but it basically creates a virtual function. So you're creating an abstract class, and then you inherit the main engine class is going to inherit from that abstract class, I think. And then because you do that, you can, and you use the static keyword. What the static does is just initialize the variable only once throughout the execution of the program, and is the same idea as static methods in Python, where even though the function is a part of the class, it's not going to change based on the instance of the class. It's more of a it kind of acts like a global variable. So you do that. You declare this with the static, and because I think it's because you declare with the static and you use this virtual, then the signature is going to be the same. So GFW is not going to complain because it's as if the function has the same signature, but the difference is that you can access the values from the class inside of the function. So this probably solves the problem. And there's another approach which I got from the journal, from his example, that I just saw here, but obviously I'm not really sure if it's going to work or not, but it's a different way, which is just, as he initializes the app, he's passing a lambda, and then he's passing the variable through, it's passing the app instance through the lambda itself. So based on this function here, I think that's what I could do is, but like I said, maybe not because of the signature thing. So I think one thing that I could do is just pass a lambda instead of passing I could pass, maybe this is a much easier approach. So instead of passing the functions that I have there, I just pass a lambda with the functions, and then I initialize the engine outside there, and I just pass the engine as this, because what this does, I think, I'm not 100% sure, I don't remember really well, but it just allows the lambda to access the scope, to access the variable, even though it's outside of the scope of the lambda. And then whatever you put on the parentheses is going to be the arguments of the function. So I guess what I could do is that. So instead of using the functions there, I just pass the lambda. It's probably, I think I'm going to try this approach first, and then if it doesn't work, I try the other one, because obviously I always prefer to try to implement the thing that is the simplest as possible first. So if I could do that, then instead of just replace core with the engine, and then it should work probably. So instead of passing like this, maybe if I did the way that he is doing there, engine, and then pass like this. Not sure what is the. It's probably because I don't have the thing. Oh, I would have to call here, I think, also. It's going to complain about the engine. But then I would pass the same arguments that this function is receiving. I think that's the way that I'm going to go. So just initialize the engine class here. Or maybe a pointer to the engine. This probably has to be a pointer. And then, but I'm probably going to think about this soft string. I am going to think about this off string. So now let me talk about the events. So the way that I'm thinking about doing this, the biggest problem is the part that is confusing is the relationship between IMGUI and the events on the application, which later on I realized that they are probably synchronized through the data. So the logic of what happens when an IMGUI component is interacted with. Not sure if that's the right way to say it, but when you change the input on the IMGUI, what happens is it probably has to be from your part outside of the IMGUI, and then you just manipulate the data. So the way that I'm thinking is that the main events come from GFW to those callbacks, then they change member variables from the engine. The engine is connected through the scene through dependency injection, and the current scene is going to be the one. So I put the stuff that is common to all the scenes outside of the current scene, or outside of the current scene update, and then whatever is specific to each scene, I just call the update function from that scene, which is the game loop. Then this is gonna have, which I don't know, like the question that I have about is what data structures I'm gonna use. But what I was thinking about doing is that I'm gonna have another function. So I'm gonna send the data based on the variables of the engine that are always keeping track of what's happening with the inputs. I'm gonna send them to this function, and this function is gonna use a data structure, which I think is gonna be, so according to ChatGPT, but I thought about this before as well. So initially I was thinking about a map. So because the thing that I was thinking about, and one of the issues is that, like, what if I have a situation where I have one scene and I want to synchronize the scene with another scene. So the way that he does it, I think on the playlist, is that the problem with that is that it only allows you to update the current scene. So the events are always related to the current scene. I think, I'm not 100% sure, but what I was thinking about is, what if I want to synchronize different scenes? So even though one scene is not the current scene, I want to change the state of what happens with that scene with another. So this is the issue. So what I thought about creating this data structure inside of the engine and then creating another function. And the function is going to be like the store, where it's going to handle the flow of data from the inputs of the GFW to whatever scene is subscribed to receive events. And then what I can do is just do like a stack, a pattern, where obviously this is going to depend on the kind of scene and if I want to synchronize scenes or not. But I could do it so that when the scene becomes the current scene, then I change the flag variable to true. And when the scene changes, it's false. So that way only that scene is going to be updated with the events. And then I could I can put other logic that is going to determine, for example, I could do some synchronization or something like that, where I link different scenes together, which will probably be similar to the finite state machine thing pattern, now that I think about it. And the issue with this one is that the problem is, if you have a bunch of scenes subscribed, then how do you decide which one's going to be subscribed first? And obviously it has to be the current scene, because it's the one that is actually actively being synced. So what I thought about is creating a priority queue, where obviously the current scene has always the highest priority. But then the issue of that is that how do you make it so that you update all the scenes that have to be updated, or you unsubscribe the scenes if you're using a priority queue, because then it becomes inefficient. So what ChatGPT recommends, and I think it makes sense, but I'm not 100% sure, is to use both data structures. So use the map to keep track of which scenes are currently updated, and then you loop over the priority queue. So the map puts and removes things from the priority queue, and the priority queue determines the order of the updates for each scene. So based on the flow of data from GFW through the engine to the event store works like a router, I think, where it's going to update the scenes based on these data structures inside of the engine. The potential downside is I might forget to unsubscribe a scene and change its state when I didn't mean to, based on events that happen on another scene. So this is an issue because I'm decoupling the logic, so that can be a problem. So if I forget to because this is the issue is that's like if I do it like this, then it's not necessarily always the case that when I change a scene, I always want to unsubscribe because then it would defeat the point. Because there might be scenes where I don't want to subscribe, I want to keep the scene active even though it's not being shown. So I can't put this logic on the abstract base class, which is going to be the template for all the scenes, because obviously they would force all of the scenes to unsubscribe when the scene is changed, which defeats the purpose. So the issue with that is that I might forget at some point to unsubscribe, and then it fucks up the state of the whole application, because then I'm changing one scene with other. And the issue with that is that the problem that this is going to have on the future is that as the application scales in complexity, it's going to become easier to make a mistake and forget about it. And this is the concern that I have, because then it's going to be one of those issues that is not going to break the application. It's just going to fuck up the state somewhere, and it might be very difficult to figure out if it is happening or not. So the challenge is how do you make sure that you minimize the chances of that happening. And then I think the answer is obviously you have to put some try-catch block or something like that, some pattern like that. But I haven't thought about too much on what is the best way to deal with this. Think about design of event store functions so that it's possible to synchronize different scenes. If I want to also to make sure the current scenes always subscribe to events, and also to decrease the chances of having the wrong scene subscribed based on the state of that. So yeah, the way that I thought about it is that each scene is gonna have, so the handle events is gonna be on the abstract class, and each scene is gonna be forced to implement events, and then obviously I don't need to put the logic on the function if I don't want the scene to have events, just declare to return or something. And then I think that the way that I'm gonna separate the IMGUI events from the app events is gonna be through. So this is something that I'm gonna read here because it is the main point of confusion that I have. But I was thinking about like if this is always gonna be the same, and I think it is gonna be the same. So regardless of which scene I have, I always want to separate what happens if the mouse is hovering, for example, over IMGUI, then it's hovering over the application. So I was thinking about whether or not it makes sense to put that logic on the game engine and then send the data on the store already, a flag variable determining whether or not the event happened inside of the IMGUI. But I think later on, and this is probably what I'm thinking right now, is that it doesn't make sense because either way I'm gonna need to update the state of the scene based on the data of the inputs, because the way that they are connected is through the data. So regardless of whether or not the event happened on the IMGUI, I need the data anyway. So I think probably the best thing to do is to encapsulate, is to put the logic inside of the function for each specific scene. But I'm not 100% sure because it's always going to be a problem where, for example, when I want to drag an IMGUI element, I don't want anything to happen on the visualization. And this is going to be the same for all the scenes. I don't see why it wouldn't be. So maybe I can do it on another way that I haven't thought about. Flow of info goes from engine to scene through this function. What is the best data structure to organize the state of the scene based on inputs received from the engine? GUI is in media mode. I think it probably makes sense to make the values of the GUI items and visualization simulations to be dependent on member variables from the scene class, which will be changed by inputs coming from engine. How frequently will the logic use to make sense of inputs is events? So the thing that I talked about, whether or not the event's happening on the IMGUI element, it's going to change depending on the scene. The way IMGUI syncs with the app is through the data. I should update the state of the scene in order for it to reflect on the app. This means I should always send events to the scene because either way the events will change the state of the scene. Changing event logic when events happen inside of IMGUI. It will be the same logic of every scene because GUI events should fundamentally be separated from visualization events. So I think it should be encoded with some data structure that keeps track of where the events happens and changes the logic of what's going to happen on the scene accordingly. So the handle events on the base class should accept an argument, should determine whether the event happened on the GUI or visualization. But this is the stuff that I'm not 100% sure. Because it's always going to be separated, so But it's always going to be separated, but I need the data anyway, so that's the issue. But I think I'm probably going to do this where I put inside of the base class, I specify an argument that determines whether or not the event happened on the IMGUI. But the issue is that I just realized now that I need to have. So this is the fundamental problem that I have, and it's kind of annoying because IMGUI doesn't have a very good documentation. So probably what I'm gonna have to do is spend a bunch of time looking at the source code. That's probably what I'm gonna do next. Because the biggest issue is I don't have a lot of clarity of how events are supposed to work with IMGUI. So based on the documentation, they say that on the brief Q&A that they have there, they say you should use this function. So this is the main value on IMGUI that determines whether or not you're gonna use IMGUI events or application events. So if this is false, then it means IMGUI is not going to capture the events and your application is responsible to capture. But I'm not 100% sure how this works. So probably what I have to do is just like your responsibility to change the value of this based on whatever is happening on the events. So that's probably what I'm going to do. But I have to clarify what's going on. Because the question is, where should I put this? Should I put this on the engine class, on the main callback functions, or on the main handle events? Because probably inside of the update function on the engine, the first thing that I'm going to have is the same thing that I have on GFW, which is a function that's going to determine what happens with the events. That's what I'm thinking about doing. So inside of the function, I'm probably going to call this, but maybe it's better to call this. I think preferably it's better to call this on the engine itself because it's always going to be the same. So I think if I can do that, it's probably better. And I think the main reason for doing this is to prevent events from happening whenever something happened on the IMGUI elements. But the question is how I'm going to know that, because the issue is that it's going to be dependent on the scene. So, but I'm not 100% sure. Maybe it doesn't matter. Because the way that I'm thinking about now is initializing this stuff on the engine itself and then keeping track of this. So this is another problem. I don't know what is going to be the relationship between this I/O and the GUI elements. But I think what's most likely to end up happening is that I'm going to have to figure this out inside of each scene because it's going to be dependent on the IMGUI elements that I have inside of each scene. So if that's the case, then I can't have a Boolean variable there on the function to determine whether or not the event happened on the IMGUI. But either way, I'm going to have to pass the data to the scene so that I synchronize with the data, the IMGUI elements with the visualization. Yeah, so I'm just going to follow this stuff that I'm thinking about now. So I'm going to finish this, reviewing this stuff here, and copy the animations, create the engine classes, think about how to solve this, the stuff on the Stack Overflow there, what is the best way to do this, to set the callbacks. Then after I have that, I'm gonna think about I'm probably gonna have to spend a bunch of time studying IMGUI, so I think next time there's stream, I'm probably gonna spend a bunch of time studying it. And I was already planning to do this anyway because the documentation is not very good, and I'm gonna probably use IMGUI very often because it's probably the best library on C++ for creating GUI elements as far as I seen. The other ones I didn't. There's Qt and the other one is WX widgets, but neither of them I liked. I don't like the structure of WX widgets, and Qt I think there's some weird stuff there that I didn't like that much. So the best one is the IMGUI. So probably gonna spend a bunch of time using this, so I think it's worth it to just do what I did with other libraries and just create a flowchart and then spend a shit ton of time trying to understand how everything's connected. So that's probably what I'm gonna do before I structure the scenes. So I'm gonna get to the point where I have whatever I have here on the example, but with all the engine structure and the scene structures, like the overall architecture of everything. Then once I get to the points and it is time to focus on the events, that's when I'm going to probably study ARM GUI first, spend a bunch of time studying ARM GUI. Then after I clarify everything, then I'm going to think about what is the best approach to structure the events. So then after I figured all of this stuff, I'm going to continue with the other, like this stuff, the other stuff that I have to do. So I'm going to stop here. Not really sure how long this is going to take, but next time probably we're going to study ARM GUI. So